Dry and wet mix shotcrete is a vital repair method in blast furnaces stack. There are two main types, dry mix and wet mix. Dry mix add water at the nozzle, giving the operator a real-time control. Wet mix premix the water before pumping, offering a consistency. So in the wet mix, consistency is a priority, whereas in the dry mix, giving a operator real-time control. So wet mix is a faster with a lower rebound and better suited for large scale job. Dry mix is a simpler, ideal for remote or small scale repair. Or we can say it's a localized repair also can be taken care. Wet mix shortcut in wet mix shortcut all ingredient including water are mixed before pumping. Compressed air is added at the nozzle to propel the slurry. This method ensure the consistent quality, faster application and lower rebound. However, it requires complex equipment and careful handling of leftover mix to avoid wastages. Now coming to dry mix shotcrete. Dry mix shotcrete uses compressed air to blow dry material through a hose. Water is added at the nozzle, allowing for operator to adjust in real time. It's ideal for a small jobs or area with a limited water supply. The equipment is simpler and hose is lighter, making it easier to move and shift. Coming to our core requirement in the requirement of the our shortcut material, we know that atmosphere in blast furnace shortcut must withstand reducing atmospheres. That means low iron content to avoid damaging reactions and high alumina or silicon carbide content for resistance to hot gases and slags. The mineralogy must be stable. No reducible oxides or phases that degrade under CO or hydrogen. Preferred material types. So, alumina based shotcrete with over more than 60% alumina resist chemical attack and maintain strength. Silicon carbide modified shotcrete offers superior resistance to coke, alkali, and carbon monoxide while also enhancing abrasion and thermal shock resistance. These materials are ideal for harsh furnace condition. Common composition element. If you see, both shortcut method use high alumina cement, refractory aggregates like bauxite or mullite, and additives such as accelerators, fibers, and microsilica. Water is essential but added differently. Add the nozzle for dry mix and premix for wet mix. These elements ensure durability and performance. Additive and operational properties. Accelerator like calcium aluminate help rapid setting, especially in wet mix. Low metallic content and dense microstructure prevent corrosion and gas infiltration. The goal is excellent addition, low rebound, and fast application, minimizing downtime and enabling quick hot repairs. The key properties for the blast furnaces, if you look on, refractory shotcrete must deliver high adhesion, density, thermal shock resistance, low rebound, rapid setting, chemical compatibility, and pumpability. This is also one of the very important parameter. These properties ensure reliable protection and efficient application in demanding blast furnace environments. So let's break it down. The property table. Addition prevents detachment, density ensure durability, thermal shock resistance avoid cracking, low rebound keep application clean, rapid setting reduce downtime, chemical resistance protect against slag and gases, and pumpability ensure ease of delivery. So, Shotcrete repairs damaged lining very quickly and reducing cell exposure and thermal cycling, which is supposed to be the biggest plus point of this methodology. Additive improve microstructure, making it dense and crack resistance. It resists chemical and thermal attack, minimizes rebounds and extend campaign life, cutting maintenance cost and downtime. In recent innovation, if we talk about, then wet mix technology reduces rebound and dust. High pressure pump reach complex zone. Fiber reinforced mix boosts toughness. Advanced admixture improves workability. And this is only not robotic system enhance safety and consistency. Tailored design and eco-friendly practices are reshaping shortcut applications in a big way. Now coming to the hybrid fiber reinforced shortcut, hybrid fibers, steel and synthetics boost strength and toughness. They bridge cracks, resist fatigue and improve ductility. These mixes and reduces shrinkages, enhance cohesion and enable thicker repairs. More even offer self-healing and waterproofing, extending repair life. Now, as for the composition and role of hybrid fiber is concerned, hybrid mixes combine long fibers for crack resistance and short fiber for shrinkage control. High modulus fibers add stiffness. Low modulus fiber improves flexibility. Common combos include steel with synthetic or basalt with polymer, tailored for strength and durability. Now coming to a question that why hybrid fibers are used. Hybrid fibers, hybrid fibers form a reinforcement network that control crack at multiple scale. They enhance compressive, tensile and flexural strength, reduce brittleness and improve durability. These mixes optimize pumpability and toughness, ensure long lasting furnace repairs.